And angle bisectors are the last special segments of triangles or special parts of triangles that we're going to study in this chapter. So, what is it? It's a segment or array that bisects one angle of a triangle. So we already know a triangle has 3 angles. We know what an angle bisector is. It cuts an angle into 2 congruent angles. There are 3 angle bisectors in every triangle, so if I take this as my angle that I'm dealing with, an angle bisector is going to cut that angle in half. That's the major thing. Now, what's the major property for an angle bisector? It's the fact that every point on the angle bisector is equidistant to the sides of the triangle. So there's really 2 major parts. First, this angle is cut in half, so angle 1 is congruent to angle 2. I could set them equal. But second is this idea that if this is my angle bisector, not only are those 2 angles congruent, but any point on here, for example this point, if I draw the line perpendicular to the side here, it has to be perpendicular because that's the shortest distance, and the line perpendicular to the side here, from that point, that's congruent. Those 2 lines are congruent. And that's true no matter where I put that point. I could put a point here and draw the perpendicular, draw this perpendicular. Now this segment's congruent to this segment because it's on the angle bisector. That's the same all along. Now, we will look at problems that utilize that. For right now, our major focus is going to be on the angle bisecting part, and we're going to have to recall and utilize 2 things. First, the triangle sum theorem, and second, linear pairs. So if I am told that ray US is an angle bisector and solve for x, I know that this angle is congruent to this angle. I know that that's true, but I don't know what either angle is. What I do know, if I look at this triangle in a different way, I know that this is 22 degrees, this is 76 degrees. I know I could find this using the triangle sum theorem. So I know that 22 and 76 is 98. So 180 minus 98 is 82. That means this is an 82-degree angle. But if I take a ray and bisect it, each one is 41. I cut it in half, and that's the picture that I have been dealt with here. We know that this big angle here is the same as this big angle here. This big angle is 81 degrees because of the triangle sum theorem. So when I cut it in half, this is 41 and this is 41. Well, these 2 are equal. 2x plus 7 is 41 degrees. Now I can use algebra. Subtract 7 from both sides. 2x equals 34. Divide, and x equals 17. Okay. If I needed to find an angle here, well, I could use triangle sum theorem again. 22 and 41, and this angle would give me 180. So using the triangle sum theorem there, I can take 180 minus the 41 minus the 22. This angle would be 117 degrees. I could do triangle sum theorem to find this angle, or I could use a linear pair to find this angle. So I could find all of my different angles. This would be a 63-degree angle. It's not necessary to solve this, but there are problems in your homework packet that are going to ask you to find one of these 2 angles and give you very similar information. So it's a matter of using triangle sum theorem once, twice, maybe 3 times, or using a linear pair. That's it for our special parts of triangles. We will have a review day next, and our quiz will be on Friday this week.